I hope you guys are seeing my screen. I need a reply.
Yes, sir. Yes, sir.
Good.
Sir, we are still in the class, sir. That's why we are still in the class, sir. Most of us are still just leaving the class. We are still in the class, sir.
Good morning, sir.
Yes, Finn. How are you? Where are
I'm fine,
others?
sir.
All right, good. So
Yeah, they're joining gradually.
You're joining gradually. Okay, some people are still making some noise. Okay, let's start. Okay, let me ask you, Finn. You are the class rep. Where did we stop? Where did we stop the last time? Where did we stop? You can't remember, right? Damilone.
Yes, I can't remember.
Oh, all right, good. So no problem. Let's continue. Okay. Well, I believe we stopped here. Oh, where's my good. We stopped here, right? We did this part. We did this. Example 2. I guess I told you guys to do example 2, or did we do it in class today? Example 2. Okay. Okay, let's start. We are still dealing with greenhouse. And you know, for you to have a controlled environment, for you to be able to control your environment, you must do what? You must monitor the environment. And how do you monitor the environment? You monitor the environment using sensors. And what are the sensors do you use? It's either you have a temperature sensor, standalone temperature sensor, or a sensor that can measure both temperature and relative humidity at the same time. Yeah, I just gave you guys an example of what a temperature that can measure both, a sensor that can measure both temperature and relative humidity. While here, this is an example of a solar radiation sensor that will measure the solar radiation within the greenhouse environment, right? So, and then why do you need to do all these things? Why do you need to measure this? You need to measure so that you're able to do what? Control. And how do you control the temperature within the greenhouse? How do you control the temperature within the greenhouse and the solar radiation within the greenhouse? You control the temperature within the greenhouse by using what? Ventilation, that's open window ventilation, air circulation fans, or misting systems, or evaporative coolers. Those are the systems through which you use in controlling what? Controlling the what? Air temperature and what? Relative humidity. How do you control the amount of solar radiation coming into your greenhouse? How do you control the amount of amount of solar radiation coming into the greenhouse? How? By using a thermal shade. One you say is that the thermal curtain, or they call it thermal screen. Thermal, the first one is, let's see, you control this one by the covering material, type of covering material. Because every greenhouse covering material has a specific amount of solar radiation that it can allow to pass through it. Most times, most of the covering materials have, the least you can have is a covering material that will allow a 75% solar radiation pass through it. All the solar radiation coming incident, that is radiating on the surface of the thermos and of the covering material, only 75% will be allowed to go into the greenhouse, while 25% will be reflected back into the sky, right? So is either you call them covering material or glazing, type of covering material or glazing material, right? And then you have thermal coatings or thermal screen. You know, thermal screen is like cotton in the house. Why do you use cotton in the house? You use cotton in the house to do what? To stop sun rays from coming directly into the house. So what does it do? It kind of provides some kind of cooling, right? By the time solar radiation is not allowed to come into the house, what happens? There is cooling. So you use thermal screen. There are two reasons why you use thermal screen. Is either you use thermal screen to stop solar radiation from entering. I hope you guys are still seeing my screen.
Yes, sir.
From entering into the greenhouse, or you use the thermal screen to keep the thermal energy within the greenhouse, right? Is either you use your thermal screen to do what? To keep out solar radiation from entering the greenhouse, or you use your thermal screen to do what? To keep in the solar radiation or the heat energy, the thermal energy that has been trapped into the greenhouse. And when do you need to? Let me ask you guys now. In what areas, what regions of the world, where in the world do you need thermal curtain or thermal screen to do what? To stop solar radiation from entering the greenhouse? Which locations of the world do you need to do that? I need an answer. You from where?
Temperate region.
What?
Temperate and arid regions.
Yeah. No.
Temperate.
No. Tropical regions now. Tropical regions have higher temperatures. Temperate are cold regions. You should get it right. Temperate regions are cold regions, while tropical are what? Are the hot regions. So you most times use thermal curtains to stop solar radiation from entering the greenhouse in the what? In the tropical regions. While in the temperate regions, you use thermal screen to do what? To keep the thermal energy within the greenhouse from escaping. Right? Is that clear? Okay, so now let me just give you. We talked about. I just want to do some little revision before we finish about this greenhouse thing. We talked about parameters regulated in the greenhouse, right? So and then look at this. If you look at these parameters, I introduced one. I escaped my mind to put this one here. Vapor pressure deficit. Among all these parameters, temperature, humidity, the most important of them all is vapor pressure deficit. Even though vapor pressure deficit is what? It's a derivative of what? Temperature and what? Relative humidity. Look at this equation on this page. Like you said, vapor pressure deficit is a derivative of what? Temperature and relative humidity. But do you know what? You guys know what? VPD is a parameter that can be used to effectively do what? Control the environment or optimize the environment. Its properties, what it controls, is far, far better than what temperature and relative humidity control can do. If you are able to keep your VPD within the range that is required, you achieve better yield, better greenhouse environment than trying to control your greenhouse environment by varying your temperature and relative humidity. So you guys should just know that. Okay, so let's go. So we did this thing, determine the heat, right? We did this. We talked about this, right? And I told you this example 2. Example 2 is formed from example 1. Example 1 says a lean-to greenhouse. So an example 2 is what? A full greenhouse, a standalone greenhouse. So a lean-to greenhouse has how many sides? I want an answer. I need an answer. A lean-to greenhouse has how many sides?
3 sides, sir.
3 sides. While a standalone greenhouse has how many sides?
4 sides, sir.
4. Yes, 4. It has 4. And then what again? The roof is complete. It's not half roof. So in solving the problems about standalone greenhouses, you know that what? You are dealing with four sides, and the roof, you have 2 sides of the roof. So do not forget. This is a solution to example 2. You guys should look at it. I just told you about the sensors used in measuring, in monitoring greenhouse parameters, right? And then we talked before about the benefits and then the disadvantages of greenhouse. And this is an example of a Gothic greenhouse. Yes, very good. Let's look at this shape now. Look at this. This greenhouse is, I hope you guys are listening to me. You know, we have side vents. I hope you guys are still seeing my screen.
Yes, sir.
Okay, good. You have side vents, right? You have side vents. You have a roof vent, right? Air will enter through the side vents. This is a naturally ventilated greenhouse. Air will enter through the side vents and then go push, air within the greenhouse. When the temperature is high within the greenhouse, what happens? The density of the air within the greenhouse does what? What happens to it? What happens to high temperature? When temperature is high, what happens to the density of the air? The density drops now. Air, why? Why does it drop? Because it has lost its what? Moisture. Do you get? So now, air that is coming from outside has what? Has more moisture than what? Air that is within the greenhouse. Therefore, when this air comes in through the side vents, what happens? This heavy air that is coming in with much moisture. And then what does it do? It pushes what? The lighter air upwards. And the lighter air does what? Escapes through the what? The roof vent. You get me? So now, using this greenhouse in a temperate region, which is cold region, look at these 2 black spots here, standing for what? Thermal screen. When when the weather is very cold, even during the day or during the night, what happens? This one side of this thermal screen, this thing rolls back down here to the eave here, to where you have to the 1.9 meters at the edge here. You are seeing the cursor. Can you see the cursor?
Yes, sir.
Okay, good. So,
Yes.
So the thermal screen on the left side comes down and stops here. This one comes down and stays here. On cold nights or cold days, what does it do? To make sure that the heat within the greenhouse stays within the greenhouse, right? Good. So let's go. And you see these 2 things here. These are the air circulation fans. This thing standing here with green, the stuff on top of it. These are the plants. And these things that you have the plants on 1.2 meters. That's the greenhouse bench. It is called greenhouse bench. You don't plant on the floor in the greenhouse. No, you plant them on a raised surface to ease movement. That's why you have greenhouse benches, right? And you see you have a heating pipe here. There's a pipe that runs from along the length of the building. Okay, let me show you guys. Yeah, good. Yeah, good. Let me show you guys something. Okay, and then look at smart agriculture. All of you, you are in different options. And what will sell you guys, what will sell any of you is not design and fabrication of a maize sheller, of a granite shelling machine, or a goosey shelling machine. Rubbish. That is trash. People, the world has gone beyond all this design and fabrication. You can decide to do a simulation, design your machine on a system using the software, do all the simulation, do all the design calculations on it, and then you see it perform. That is what you can even sell out, right? You can sell that idea. Not all those machines that are fabricated and kept at the department there. What's the usefulness of all those things, right? So see, agriculture is becoming smart. It's not just about, say, you go and plant in the open field, and even the open field, application of smart agriculture on the open field gives you greater yield. So everything is becoming smart now, you know? So let me show you guys something. Can you still see this file? What are you people seeing now? You're still seeing, which one are you seeing? What are you people seeing on the screen? Okay. So let me show you. Let me show you guys what. Okay. I can hear you. Okay. Good. Can you see this? You see this greenhouse? Can you see?
Yes, sir.
Good. So this is very good. I'd like I told you, when you have this kind of a system, what you're saying, irrigation and nutrient system, what does it do? Reduces wastage, right? And good. Look at you see these lines, A1, A2, A3. That's the length of the what? Of the greenhouse bench. They are long, not that they are short stuff. They are long, depending on the length of the greenhouse. They go along this thing like that. And then on top of them, we don't have soil. You don't use soil to plant in the greenhouse. It is what do you use? Use rice husk, coconut husk to plant, right? Okay, it is okay. So basically this is good. Very good. You see? Now, who can tell us? Look at this. Let me show you. Look at this. Look at this greenhouse. And then look at this one. Right? This one, let me just tell you guys so that I don't waste my time. Look at this. This one has what? It has a triangular cap, right? This one is kind of a semicircle cap, which only one side is open. This one, two sides are open, right? So let me ask you guys now, which of these two greenhouses will have a better environment? Please answer me. Which of them? Is it this one?
Yes, sir.
Why? Why will this one have a better environment than this one? So why? Give us an answer. Who can tell us?
Because the greenhouse is having more intake of air than the semi.
No, why? Okay, where is it having? Look at, it's the same. The side vents are the same. Same 1 meter. Same 1 meter. They are all the same, except the cap on the roof. Look at this figure. This figure 2 will have a better environment because of this cap. Because the cap has two faces. Air can escape here, air can escape on this other side too. Why
Heat
this one
exchange.
only has, yes, why this one has only one, right?
Yes, sir.
Good. So let's continue. Your sharing is post. Why is it post? Okay. Yeah, sure. Okay, good. So let's continue. Smart agriculture. Okay, good. Loads on structural. Good. So now we are entering gradually into design of structural members. And you know, to design a house, a farm structure, depending on the kind of a shade, right? You need to, first of all, evaluate how much load is this structure or this member going to carry throughout its lifespan, right? So you need to know that. Even in construction of roads, you need to estimate how much traffic of small cars will you have on that road? How much traffic of heavy duty vehicles will you have on that road? By the time you have all these estimations, that is when you go into what? Proper what? Construction. So, and you know, they say meetings will end in 10 minutes. Once it ends, you guys can join again, right?
Right.
Okay, so you have different kinds of loads. You have snow loads, but fortunately, we in the tropical regions, we have no issue with snow. So snow is not our problem. But we have what? Wind, we have stored products. Stored products are basically for what? Are basically for what? Structures like what? Structure like silos, right? Like storage structures. Huh? Installed equipment, right? Like processing centers, right? And then other building components, which are called what? Dead loads, right? Like the weight of the building itself, the weight of the roof, the weight of what are called the building itself, other components of the building, and all that, right? So you have wind. So let's go. Reactions. You know, so for the structure to resist applied load, there must be what? A reactive force, or what? A resistance. You know, right now is either you are sitting. So if you are sitting, the chair you're sitting on is resisting your weight, right? Is resisting your weight. If not, if the chair is not strong enough and your weight, okay, and you are heavy, what happens? The chair breaks. That means what? The resistance provided by the chair is not enough to resist your weight. Therefore, any structure, seats, anything that is constructed must be able to resist applied load. Forces that resist applied load, they say they are called what? Reactions. You guys should be answering me. They are called what? Reactions. And then structural members in which the sum of reaction just balances what? The loads are in what? Static what? Equilibrium. Static what? Equilibrium. The form. Okay. So this thing, okay, 7 minutes to go. Simplifying assumptions, you know. It says what? So we're going into beam design now. Yeah. Okay. There's oh, what I mean, beam. Okay. Okay. So what are the assumptions? Okay. All right, thank you. Okay, what are the assumptions? It says what? Beams are assumed to be plenary what members. That is what? All forces act in the same what? Direction, either along the same line or in what? Opposite direction. I'll show you now. Look at this. Right? Look at this. It says what? Beams what? Look at beams are assumed to be what? Plenary members. That is, as a plenary member is what? It's a member that what? That receives forces that act in what? In the same direction, either along the same line or in opposite direction. Look at this. P is the force, is the applied load on this beam. P and W. W stands for what? W is weighted distributed what? Load. W is distributed load, right? Distributed load, example of distributed load are what? Second floor decking of a building. Guess you guys are understanding me. Decking of a building is what? Distributed load, right? And then if you go to the farm environment, if you have a platform and you spread your garri on the platform, that is what? Distributed load. Why P is what? Pointed
Point load.
load. Yes, point load or pointed load, right? Acting at a singular point. Now, look at this. These loads are what? Are pressing on the beam from the top, while the reactions are acting what? Upwards. Are acting what? Upwards. And it says that what? A beam is a plenary member, right? That what? All forces act in the same direction, right? Either along the same line or what? Opposite direction. So this is what a beam means. So a beam is a plenary what? Member. Understood?
Yes, sir.
Good. So now let's look at this beam now. You see figure A and figure B. For you to call what something a beam, it means that what? The length must be greater than B. And look at figure B. You see what B is. B is like the thickness, right? B is like the thickness, and D is the depth. They call it depth. Now, oh, I'm not seeing you guys as well. I cannot show you, but I guess you guys, if you, oh, very good. How many of you know a 12 by, is it a 2x4 plank? This plank used in constructing a truss. Just carry a plank. Very good. I'm going to give you, this is going to be assignment. Assignment now is, you guys are going to buy a 2x4 plank, a 2x4 and a 2x2 plank at the sawmill at Tanke, opposite Mark, or is it beside Mark? I hope you guys are understanding me. What did I say you're going to buy? Fee.
Can't we just gather the back and do it?
Gather what?
Let us all gather the, like, maybe one of us will buy the plank, sir.
And that's what I'm saying now. You can gather money, one person will go and buy it.
Okay,
and then bring
sir.
it to school. Yes, that's what I mean. Not all of you together and go. So you buy a 2x2, one piece, and a 2x4, one piece. And the length of a standard lumber, standard timber? Who can tell us what's the length of a standard timber? It's 12 feet. Simple. So just go there. The 2 by 2 means the surface area, the surface dimension. That's what they call it. 2 by 2, not the length. You don't go and say 2 by 2 by 12. No, it's 2 by 2. Those people, they know it. 2 by 2, and then 2 by 4. The length is assumed to be is the same, so it's 12. So a beam is a member that the length is larger than the B and the D, right? Oh, this thing will go off very soon. So once it goes off, you guys just click to join again.
Understood, sir.
Okay, look at this. This is just showing you forces acting on a beam, right? Okay. Any questions so far? None, I guess. This is still same. Same. Look at this. Let's still look at this beam. This beam, you can call it what? Simply supported, is it not? This is what? This is an overhanging beam. Cantilever, is it not? Cantilever. This is a cantilever, not an overhanging. It's a cantilever, right? Supported at one end. And then this one is what? This is